Today's little lesson is on Hooke's law. This here is our spring, and that there is a fixed point where it's attached to something and it's hanging. Down here's just got a loop where we could hook something onto it. So that there is the overall length of the spring. We're never really interested in the overall length. What we're interested in is how much it changes when a force is applied. So this example here, we've got and attached a big heavy mass on just there, and the spring has been pulled down and it's been stretched. So what we're interested in is the difference here from what it was before we applied the force and what it is now. That there is given the symbol lowercase x, which is for extension. So that spring extension is x. You can see that it actually also works on compression. So if we were able to push that up and it started to look like that one instead, then the extension would be how much shorter the spring got. So x for a compressed spring would be that one there. If we go and look over here, we can see, so we've got our formula is F is equal to Kx, by the way. Sometimes you might see it written as F equals Ky. So X and Y are both used for the extension of the spring, but I think for SciPad they'll be using X. So force is just the same old force, and that's measured in newtons, capital N. K is the same old as spring constant, so that'll be new to you. And spring constant is unique to every spring. So if you get a really strong spring, like a truck, then it has a large spring constant. If you have a small flimsy one, like out of a pen, then it will have a smaller number for its spring constant. Every spring has its own unique spring constant. And X was extension. And extension has got to be in meters. I'll just point out that if you want to find the unit for K, for spring constant K, you can work that out from the formula here. I'll do it just down here at the bottom of the page. So K, if we rearrange that equation, K is equal to F divided by X. F is measured in newtons, and X was measured in meters. Therefore, it becomes N/m, which simplifies to Nm-1. So that there is the unit for spring constant, is Newton meters -1 is its unit. Alright, so we're going to have a go at this question here. We've got a spring, it's compressed 20 centimeters by a 35 Newton force. What is its spring constant? So we write down our formula, same as what we were learning last term, F equals Kx. Rearrange it, K is therefore F divided by X. Now we can substitute in our numbers. F is going to be 35. And here's our little trick. It's been given to you in centimeters. You need to know that there is 0.2 meters. And then you do your calculation and it works out to be 175. And we know from just down here that that is going to be Nm-1 for its unit. Thanks for listening.